Hello, this is CC615 Cloud Infrastructure class, Week 4, Network Part 1. This week we will start with reviewing of networking basics, talking about OSI model, IP addresses, public and private, and CIDR notation. Next, we will talk about virtual local area networks, defining them, and talking about different kinds of IP addresses in VLANs, like public, dynamic, static, private, and so on. And then we will talk about the virtual network security and separation, covering firewalls, VPN protocol, network separation, and security groups. Review of networking basics. The OSI model. Computer networks connect different computer components together. These components have their network interfaces, like the NIC cards for servers, connected by wire, fiber optic, radio, satellite, etc. Hubs, switches and routers direct and manage the network traffic. All of these network devices implement stacks of hardware and software protocols following the OSI networking model. This is a 7-layer model in which each layer uses the services of the layers below and provides additional services to the layers above. Click on this link to review the OC model description video. A popular OSI stack is the Internet Protocol, also called TCP/IP suite. It splits communication content into packets. The IP protocol is responsible for delivery of packets and network addressing. TCP is responsible for secure and reliable splitting and reassembly of packets. On top of TCP/IP, higher-level protocols such as HTTP, Hypertext Transfer Protocol, the communication language of World Wide Web, are defined. IP addresses. Servers, physical or virtual, also called hosts in networking, not to be confused with hosts for virtual servers, are addressed by using IP addresses. IP addresses exist in two forms: IP version 4, older and running out of address space, and new version 6. Even though IP version 4 is older, it is still used in many applications in the cloud. IP version 4 addresses are 32-bit entities. They are often split into 4 bytes and written down as 4 decimal numbers in the 0 to 255 range, which is the numeric capacity of a byte, separated by dots. For example, 10.11.30.252. The IP version 4 format allows for over 4 billion unique IP addresses. While this was more than enough to handle demand during the 1990s and 2000s, it is not nearly enough to keep up with demand today as in the future. To solve this problem, IP version 6 has been introduced, extending IP version 4 addresses from 32 bits to 128 bits. Cloud vendors are getting ready for IP version 6 and must allow for specifying IP protocol version when provisioning servers. Private IP addresses. In order for IP version 4 addresses to be used efficiently, 3 blocks of IP addresses were separated and reserved as private IP addresses. Local smaller networks access the internet through a router, which can have a unique public IP address, and it can take care of internal addressing within the local network using private addresses which don't have to be globally unique. This is similar to a company having a main phone number which is globally unique, an internal extension number for its many internal phones which the main number switch handles and which don't have to be globally unique. The 3 private address blocks ranges are Class A over 16 million addresses, Class B over 1 million, and Class C over 16,000, and the ranges of addresses are shown. The first and last address in each range are reserved. Your home internet router has a unique global IP address and likely uses Class C private addresses for your home network devices. See the link provided for more information about IP addresses. In addition to IP addresses, TCP/IP communications also use port numbers, communication endpoints on a server assigned to various higher-level communication protocols or applications. For example, port 80 is a default port reserved for HTTP communications. CIDR notation. The CIDR notation, which stands for classless interdomain routing, is used for defining blocks of IP addresses. In this notation, the number after the slash specifies how many bits in a 32-bit IP version 4 address are intended for the network or global address. Remaining bits can be used for host addresses which are internal inside the network. For example, 20.30.40.0/24 defines a network address of 20.30.40, which is designated by the leftmost 24 bits, and it always adds 0 at the end, and leaves 8 bits for 256 host addresses within the block. The bitmap of the network part, specified as an IP address 255.255.255.0 in the example above, is also called the network mask. CIDR notation also allows for specification of subnets, which are sub-blocks of IP addresses within larger blocks. You will need to understand the CIDR notation because cloud providers use it for specifying details of networks and subnets used when provisioning servers. See the link provided for more information about CIDR notation.